Okay, in this video we're going to erase an NVMe disk, and this builds on what we did in the previous video, which was part 45, which was wiping MMC disks. It's just a small extension to that, and we're going to it builds on parts 38 and 39, which is modifying the Linux bootable pre-execution environment initRD to modify the startup and boot from a USB, which is part 40. So I'm just going to show you what's on the disk before we wipe it. There we are. So there's data there. It's actually a bootable sector. We'll just go ahead and wipe that. So there's the NVMe disk. Yeah. So it's actually doing a format with secure array setting type 1, which we'll go into later. And that's wiped it. So we're going to have a look. So it's all zeros. So that's it wiped. Right, now I'm just going to show you how this all works. Okay, so now I'm going to show you how it works. And the key to this is this tool nvme-CLI, and depending on your version of Unix, you may already have this installed. So do a let's show you. Do an nvme ---- version. That's the one that's installed, and you should see, well, something like this. Now in my case it was 1.9. Now 2.7 is available. And I have actually built it. There it is there. So if you don't have NVMe installed, your only option is to build it. And you build that by downloading this. But you should use a version which is more closely aligned time-wise to your sort of Linux kernel, your Linux distribution. So scroll down to sort of around here, and what's this one? 2.2. I actually use 2.21, which is sort of bug fix for 2.2. These builds are pretty gnarly. Very much depends on the state of your distribution. It's built using Alpine Linux, and I'm trying to build it on Ubuntu Linux Mint, well, 21, and you get things like this. This one does actually work, and I'll just show you the result of a build. First thing to do is you may have to update the certificates. It's worth sort of doing anyway, because it does down here start downloading. Well, there it has. It's downloading this. So you do need the certificates in place. It then goes ahead and builds them all, downloads them, and all the rest of it, and eventually completes, and you get a thing finishes. So that's how you'd do that. Now, getting it into the image, which was described in part 18, create a Linux Pixie bootable image using dev bootstrap, is better to put it in the image rather than build it in the image. If you try and build it in the image, it's going to install all sorts of other bits and pieces that it's using during the build process, you know, Ninja and Meson and things like that, which you don't need except when you're building it. So what I do is build it outside the image and then copy it in. Copy in the executable and any libraries that it needs, and then recreate the image, all described in part 18. So that's NVMe, and the scripts here. First one's erase script, so you can just update this. Now NVMe does not allow access using hdparm there, so all this bit skipped, which was just doing things like estimated time of erase. and goes straight into wipe drive. And if the device drive, which is passed over, is an NVMe drive, it executes this. It gets the size serial model in the same way as SATA, but MMC doesn't, if you look. And then it goes ahead and does an NVMe format using the secure erase setting, which I set here as 1, and formats it. This takes seconds to minutes. It's pretty quick. There's no progress bar or anything, but and we don't have an estimate how long it's going to take, but eventually it does, or of course it might fail. And if it fails, it uses this this thing, and all these scripts will be in the in Git and in the comments. Fail will print failed, big and bold in red, so that if you have a number of machines on the in the workshop, you can immediately spot any that did fail. Now, there's no difference in all my tests between the sort of earlier version 1 and 2 when it comes to failing. What seems to fail is machines that do not allow you to send over the IO control character to actually initiate the erase. So in that case, you have only recall. Well, it depends what you want to do. You might have to update the BIOS, take out the disk, put it in one that does allow it, and take it from there. Okay, so that's the scripts, and I just wanted to show you what the secure erase setting is, because it's kind of key. This is it, is it? Yeah, here. Secure erase setting, and the one that we want to use is 1, which is user data erase, all the users erased, but also, interestingly, the controller may perform a cryptographic erase if that's well, not necessary, but if that sort of works, if the data is encrypted. So that's the one to use. If you do use 2, it just does a cryptographic erase, and that may or may not be appropriate. So use 1. Now we are using the lowest common denominator here. That's secure erase setting 1 and format. That's because, as I said before, version 1 does not have, only has format. It doesn't have sanitize. And I'll go into the use of sanitize in another video. But format is really quite sufficient. All user data is erased completely back to the disk. Okay, well, thanks for watching. See you next time.